Hey, how you doing? Today we're gonna be talking about higher order derivatives. So if you've gotten until this point in calculus, you probably already know that a derivative can be a function. Basically, if we define any function f of x, so let's say we have f of x is gonna be equal to 3x cubed plus 10x squared. Now let's say this is our function. We know that if we take the derivative of that, well, what we're gonna have is gonna be another function, which we know is gonna be 9x squared plus 20x, okay? This is just the power rule. Now we know this is a function right there. Now I want to ask you something. What if you wanted to take the derivative of this function? Remember that if you're going to take a derivative, well, you need a function because you're going to apply that operation to that function. And technically, since this is a function, you can take the derivative of it. Now, what does it mean to take a derivative of a derivative? That is what we called a second or a higher order or second order derivative, or simply second derivative. So basically, the second derivative, let me write it, is going to be, you can see it like this. If you have, for example, dy over dx, and it's just simply any type of function, we could say dy over dx is going to be 9x squared plus 20x. What if you did this? You apply the derivative operator to dy over dx. What would happen if you did this? Okay? Now think about that. Now, algebraically, it's going to be the same thing. You basically do not need to learn anything new. You're just going to use the power rule here. So basically, this would be the same as if you did the derivative with respect to x for 9x squared plus 20x. And you know how to do that. That is just simply going to be 18x plus 20. Okay? Now, this is the derivative of the derivative of 3x cubed plus 10x squared. That is how it works. So let's go back to this example right there. Remember, we had a function f, which in a xy plane, we could say f of x is equal to y. And then if we take the derivative of f, or just simply dy over dx, we're going to have 9x squared plus 20x. And now what if we took the derivative of the derivative of f, which is d over dx of dy over dx. It's basically this operation. Now you can write this part in a more compact way. You can basically say that if you have y is going to be equal to your initial function, okay, same thing as f of x, 3x cubed plus 10x squared, you can say that d squared, you could say, although technically it's not a squared, but you could write, it's basically as if you're squaring, but mathematically it's not, over dx squared, once again, just so you understand. This is going to be equal to taking the derivative twice of the function. So this is going to be equal to the derivative with respect to x of the derivative with respect to x for y, basically. So for 3x cubed plus 10x squared, okay? Now, this is the notation we use for higher order derivatives. So if you're going to take, for now, this is, in this case, this d2y over dx squared, let's say squared so we can say it faster, basically, but remember, it's not squared because you're not multiplying, but just for the sake of language, this second derivative of y is going to be this, okay? Because remember, you're going to take, first of all, go from the inside to the outside. So if you have, first of all, the derivative of 3x cubed plus 10x squared, that is just going to be f prime. And if you take the derivative of f prime, which is dy over dx, which is what we did right there, you're going to take the derivative of the derivative of the function, which is going to give you this. So we could say that the d2y over dx2 is going to be 18x plus 20. Okay? This is how much you get. And now, of course, you can, for some functions, you could technically find dny over dxn. You could find the nth derivative of a function. This happens, of course, most of the times when you have a pretty big function that you have to do a lot of times the chain rule. Okay, you can have basically almost infinite derivatives, or for some trigonometric functions, you have n infinite, infinite derivatives, but infinite derivatives of derivatives, basically. So n can be basically any number to infinity. So that is how it works. I hope now you understand what higher order derivatives are. They're pretty cool. And well, we're going to be doing some exercises with them in the next videos. So I hope you guys enjoyed this video, learned something. Don't forget to subscribe, and see you in the following one.